Okay, ready?
Yeah.
First, spirals out. I want you to very, very, very quickly look at your 2-7 and your review. And if there are any glaring, like, oh no, I didn't know what to do, please go ahead and help me identify them now. I'm not promising we'll have time, but if we do have time, we're going to run through questions. We're going to start with some review, talking about the test tomorrow, etc., etc. And then if we have time, we'll get people up to the boards and or myself to give clues for ones that you're like, yeah, no, it's not working out. Yeah.
74 on the test review.
Okay. What else? On the review or 2-7.
29 on 2-7. Yeah.
Which one is that?
Shadow.
Shadow.
Eyes, shadow.
Yeah, that one's right. What else?
20.
On this one?
Yeah.
So that's when we started yesterday, but we didn't do it. I heard that yesterday. I tried to load, but I must not have published. Something didn't go right, so the evens didn't get posted online in the video, but now they are online. So if some of you guys were looking for the evens of these with the solutions, I went through and I remember in period 1 I said I taped it and don't pause. They're up there now just in case you were looking last night. I apologize. Carla, what else?
104 on the
Okay, 15 more seconds. Anything else? All right. Remember, this is only if we have time. Okay? But if we have time, we're going to get to these questions, and we don't have too many, so I think we'll be able to go through them. But first of all, you guys, your spirals off to the side until we come back to them. Okay? Off to the side until we come back to them. Here's what I have for reviewing. Do you have a test review to do for homework? Yes. What is due tomorrow before you start your test?
Homework.
Your spiral and your notes. Now let's listen carefully, just so that we can be super in the zone tomorrow. We can be tuned in. We know exactly what's going on. Before you can start your test, listen carefully. Your spiral is going to get turned in up here. The order doesn't matter. You're just putting your spiral on this table. Sound good?
Yeah.
So what do you still have that needs to come to me? If your spiral's up here.
No.
Notes. Your notes. You are going to just, as a group, you're going to put all of your notes on one desk. Whoever is the last person to get here is probably on their desk, okay? You're going to put all of your notes on a certain desk. Now, some groups have an empty chair somewhere close to them. They can put all of their notes and then all of their notes, right? Same thing in the back. Same thing with, Josh, Kara, and, wait. Cameron, who's in? Awesome. And then Eileen. And then Eileen's just absent today?
I was a lot of
Oh, right. Okay, I wasn't tracking. But I'm taping so you can see it later. Okay. Anyway, in the groups where there's an empty desk, you can put the notes there. If you want a group in the back, you can put them on the TA desk, stuff like that. The only one that doesn't really have an empty desk will be these two groups. I'll just put the stool in front. You can put your notes right there. Okay. So the notes are turned in. The spirals are turned in. What do you need to have on your desk? Piece of paper, pencil. You can bring a calculator, but I'm trying to make the related rates problems nice answers like 6 pi or square root of 10 or I don't know, something others, where you don't need your calculator because to be honest, the time it takes to say, ooh, da 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 da, didn't match. Did I put it in right? You're wasting time. So if I can keep you not using a calculator, I will, but you can bring it just in case. That way, if for some reason I can't make all the answers non-calculator, then you'll be ready. You probably want extra time on the test.
Yeah.
Which means you are coming in here to start it at 12:45. To be passed out at 12:46. So maybe you're coming in at 12:40 to get ready and set up with your spiral and your notes and your piece of paper and your pencil. Everything else is cleared off. Okay. You can start at 12:46. I guess technically, to be fair, with period 1. You can start at 12:46. Now listen carefully. I have kids, the last test especially, that came in late and wanted more time and kind of pushed it to the bell and went into their period 7 and here's the problem. If you want more time, what do you need to do? Be here at 12:46 with your desk cleared off, ready to go. So really be here at 12:42 and take the few minutes to get your stuff all ready to go. Sound good? If you don't come early, you don't get extra time and that's your fault, not mine. Okay? Can I have someone who's going to text Eileen and be like, remember, you can come early? Nice. Do I have someone who can text Tom?
No,
You text Tom? Thanks. And just be like, hey, you can come early. That way they have that chance for time as well. And then, Gabby, who did you do next? Oh, and then I moved up. Okay. All right. Any quick questions about logistics? Test review, do you have to write problems or directions? No, just practice. And you have to have your test review to get full points on your homework for your spiral. Kiddos, here's what I have for today. Remember last test? There was a test review, and it's a homework, and it's great to work through, but I had some extra problems. I have some extra problems this time too, okay? So we're gonna work through those extra problems. I technically have some multiple choice. I think I have one long answer in here as well. And so we're gonna try to get to these multiple choice. If we don't get to these multiple choice, they're saved in the notes and the answer key is right there. They're saved in the notes and the answer key is right there. But before we get to those, can we just, in our composition books, can we just work through a few big ideas? And if you're like, but my composition book is filling up, okay, go to the back of your spiral. I don't care, go somewhere. Let's work through these big ideas. Back of your spiral composition book, whichever one you're less afraid of filling up. Chris. Yes, all right, I have some big questions, some good things just to review ideas. Okay, so let's work all together on reviewing ideas. As we have time, we'll go ahead and get back to those multiple choice. And then as we have time, I might not go through all of them, but we'll do at least a couple indicative ones. Then we'll see if we can get people up to the boards and we'll just try to have a little bit of time to work. Sound good? To me, it sounds good, so we'll just okay. When you see find equation of a tangent and normal, we'll get to it. Find the equation of a tangent line. What should you think? Derive, that's part of it. And plug in, that's another part of it. And point slope. Derive, plug in, point slope. 3 keys, 1 problem. So, I'm going to get my point slope ready to go. Okay? And my tangent line is going to be y minus 3 equals somebody x minus 4. Right? What's my goal? Derive, plug in. True? Oh, how do you derive him? Y is not by himself. That was all of section 2.5, implicit differentiation. With a DDT? No, there's no time changing, expanding, something being blown up or whatever. Let's just take a derivative. So, ddx ddx, right? Okay, you guys, walk me through it. Derivative of the first part. Good, keep going. Keep going. Times dy dx. Remember, the x is matched, it was just times 1, didn't matter. The y and the x don't match, so dy dx. Equals, don't forget, derivative is 0. Where does this lead me to? Some of you, the algebra is messing you up. How would you solve? Subtract the 2x and then divide. The 2's cancel, you get negative x over y. Are we okay? Now, oh, no big deal. I just go put negative x over y. Dun, 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 dun. Of course, that's a line. What do? Such that you have the point 43. So question, what is my dy dx at the point 43? Negative 4 over 3. And as long as it's not a multiple choice that you have to make match, you're done, right? Question. We haven't seen this word normal a lot this year, but you saw it a couple times last year, and people in physics, you should have seen this a bit. What does normal mean mathematically?
Standard.
No, not standard, not original. Normal specifically has to do with slope. It's not parallel. It's the other one. Perpendicular. Normal means perpendicular. Yeah, you can have a lot of fun with that one with friends, but come back. Normal means perpendicular. Well, how do you do perpendicular? Well, you say it's the exact same point, but what happens to the slope that you already found? Opposite, positive, reciprocal. Dun, 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 dun. Huh. And we'll keep working on that. But normal, just a word that AP guys love to throw in and be like, hopefully they know what it means. You just find the derivative, and just make it opposite, reciprocal. So negative turns to a positive, and instead of 4/3, it's 3/4 done. And hence why we do opposite reciprocal slope. Josh.
Normal is always perpendicular to the.
In physics, that can be an application.
That's why it's called.
That's why it's kind of normal. I don't know. That's a good question. I'm not sure which one came first, if you know what I mean. Okay, keep going. Next one. Ooh, find. Wait, isn't that the same equation we just used? So what's the difference? Oh, okay, so hold on. Who is the first derivative? Let's start there, because you guys just found him, right? Negative x over y, not the -4 and the 3. That was just one value of the derivative, right? Okay, so the first derivative, negative x over y. How do I find a second derivative? Good, go again. So second derivative, I need to derive, again, d dx. What rule am I going to have to use? Good. On the left, I get d squared y over dx squared, right? On the right, you guys say quotient rule. I do too much math for you anyway. Just kidding. You guys go. Tell me what to do. And d top is? Keep going. Minus, it's a quotient. What's the derivative of the bottom? dy dx, right? All over bottom squared. Oh, of course. There's going to be an answer that just matches that one perfectly. No. They don't want a dy dx in there. What they want only x's and y's. So how do we approach simplifying? Who is he? Plug him in, right? Then we end up with negative y plus x times negative x over y. Oh, those AP guys, that's simplified enough. We'd be fine. What do they see that they don't like and that they expect you to simplify? The complex fraction. So how are you going to simplify it? Common denominator. Sure. Can I do my trick? Just don't forget, he goes to both, right? So now what? Negative y squared. Keep going. Minus x squared because the y's cancel all over y to the power of. Dun, 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 dun. What's the one thing they might do? I guess they could put a negative like in the very, very front, and they could say y squared plus x squared. When you see a y in the very, or no. When you see a negative in the very, very front, does it apply to only one guy or everybody? Everybody on top. Couldn't be top and bottom because that'd be negative over negative, which is positive. But it is proper if you pull out negatives from both to just make a negative of the entire fraction. Okay. Anyway, done. What did we just review? 2, 5. Where are we going next? Oh. What's this? Logarithms, wasn't that so last chapter 2a, whatever? Isn't there a rule for this? F of x to g of x.
1 over x ln b.
Sadly, no. There's no ln. We can't use 1 over u times u prime.
Oh, that makes sense.
We can't use b to the u times u prime because there's no constant in the bottom. That's an x in the bottom or in the base. The only way to solve a problem f of g, if you want, you can write it down. The only way to derive an f of x to a g of x. That's not an x to the n, that's not a b to the u. The only way is to take an ln and pop the power down. The only way is to take an ln and do what to the power? Pop it down. This is not a derivative, this is pre-cal. When you put an ln, you can bring the power down. Have I derived anybody? Nope. Then have I gotten that power down? Yes. Why did I do that? Because I wanted to find a derivative, and the only way to find a derivative, there was no rule for that, was to pop that power down and then say, all right, fine, whatever. I'm just going to use product rule. Oh, I wrote ln. Why did I write ln again? I have no idea. Go away, little ln. It was supposed to be ddx. There we go. ddx of the left, ddx of the right. Alright, I'm done. No more explaining. You guys tell me how to go. Those of you that couldn't answer that question, what do you need to study before tomorrow? Your forevers, your derivative rules. You gotta have them down or else they're gonna bite you. Somewhere where it hurts. The other side. Second. D first. How did Kyle do that so fast? Because he's awesome? Yeah, he is, but that's not necessarily why. What was he thinking? Probably. Quotient rule? He did all that in his head? He rewrote. Probably. 2 over x to be 2x to the... Oh, that's how he did it so fast. Hold on to -1, -2, x to the -2, put it down. Just saying, that probably would be a little easier than quotient rule. Sorry, second d first plus first d. My goal is to solve for dy dx. So, 1 over y dy dx equals -2 ln of x over x squared plus 2 over x squared. Yeah, I can simplify some stuff on the right, but first of all, what do I have to do on the left? Get rid of that y. He doesn't belong. I just want dy dx. What am I going to do to this entire side over here? Multiply by y. AP guys, that's good enough, right? You know who y is. Who is y? Plug him in, right? And usually he's smaller, he's shorter, so we write him in the front. Just for simplicity's sake. X to the 2 over x is y. I have -2 ln of x plus 2 all over x squared. I guess they could like pull out a 2 or something. Maybe they would. It's just your goal to make it match. We okay-ish? Couple more seconds so some of you are ready. All right, we reviewed implicit. We've reviewed the first derivative, second derivative of implicit. We reviewed tangent lines, talked quickly about normal, perpendicular, opposite, reciprocal lines. Talked about the second derivative of implicit. We talked about that. Talked about what to do if we have an f to the g. Pop them down, put ln. What's next? Ooh, 2-6. 2-6. Use your forever card. What's our system? What's our formula? All right. How do we use the formula? Do I need f prime? I get 3x squared plus 2. What else do I need to do to get ready to plug in? Yeah, I have to say, uh-oh. This is a 2 of him, which means he's a y of him, right? So I need to go ahead and solve. Ooh, how do I solve to get my b? Equal the entire original function to 2. Oh, it's a cubic. I'm supposed to do synthetic division or long division and figure out the factoring of a cubic? It's going to be something easy. Plug in 0, negative 1. Plug in 1. 1 plus 2 is 3. 3 minus 1 is? Right? There's the 1. The 1 matches the who? The b. So therefore, plug it in, plug it in. And f inverse prime of 2 is 1 over f prime of 1. You guys remember him? Remember the system? PEMDAS. I know just a few of you that would have said 9 plus 2. PEMDAS. 1 squared is 1. 1 times 3 is 3. 3 plus 2 is 1. Do you have the answer and process? Okay. That was 2, 6, yeah? What? Free response. We're not going there. What do we need? We need 2, 6b and we need 2, 7, yeah? Alright, let's go look at our multiple choice. Ooh, there's 2, 7. Let's go find 2, 6b first, though. Anybody 2, 6? Ooh, there he is, number 3. You see him? Ooh, how do you take a derivative of arc sine? Who is arc sine? Oh no, sine inverse has a derivative formula. I'm supposed to know. You're supposed to know. Good thing I know it, huh? But you need to know it by tomorrow. We're just going to write it real quick. Some of you are saying it just so we can reference it. Arc sine of u is equal to, just kidding, ddx of 1 over. What else do you need to know for tomorrow? Cosine, arcsecant, arccosecant, and arccotangent, and arctangent? Basically 3. Just make sure you know all 3 really well, yeah? All the C ones have negatives. Okay. Just looking. If you were just to guess something right now, what would you eliminate? C and D, because you're like, that's arcsecants, silly fools. What were they thinking? The answer is one of the C or D's. Gotta work it out. What do we do? F prime equals, who's you? I know you don't like him, but who is he? Who's inside arc sine? There you go. Ooh. Times. It's okay, you do what you gotta do, right? Ah, u prime. It was bad enough just to say, okay, hold on. U is 1 minus 4x squared to the 1/2, right? All right. So bring down the 1/2. That's going to be a 2 in the bottom. What's going to happen to the power when I bring down the 1/2 and then subtract 1? To the negative 1/2, which means he's going to be down here. But what can I not forget? And u prime would be negative. Okay. There it is. Oh, doesn't match any. E, none of these. Keep going. No. What can we do? What happens with the square root squared? Then what do we get? Well, there's a negative 8x at the top, and then we have the square root of 1, distribute the negative, minus 1 plus 4x squared times 2 square root of 1 minus 4x squared. What happens to 1 minus 1?
absolute value of 2x.
Or absolute value of 2x or 2 absolute value of x, either one technically works. But the forward has no bearing on it. Times 2. Aww. What's 2 times 2? 4. What's 4 and 8? Who is he? Not only is it the one with an absolute value, it's also the one with a negative. Who would have thunk from that? Carla, go ahead. Oh, u prime. So I brought down the 1/2, derivative of the outside, keep the inside, negative 1/2 times u prime, 0 minus 8x. Does that make sense though? Because your u has an outside and an inside also. So derivative of the outside, keep the inside.
Why is it positive 4 in like the first?
Oh, because the negative distributes. Those little seals, they're just flapping in front of you and you're gonna run them over. What else? Makes no sense, right? Cats can run in front of you, so do dogs. Seagulls, I don't know. Are we good? Okay. Oh, Amy, go ahead.
How did you get the absolute value?
Okay. This one we had a little discussion in class. It's a little bit messy. This goes away. I have the square root of 4x squared. The square root of 4 is 2. No big deal. The square root of x squared. When you square something and then take the square root, there is no way without imaginary numbers to get a negative. So this square root of x squared is always positive. As soon as I cross, it's not going to always be positive unless I keep or put in absolute value bars. So the absolute value maintains the sign that I need. So technically you can think the square root of x squared is always absolute value of x. Just sometimes, depending on the context of the problem, the absolute value might not make a difference. In this one though, it definitely did. We couldn't reduce, and if we did, we would have picked the wrong answer.
What if we were to have a higher power than like square root of x to the 3?
Well, square root of x to the 3 would be like a weird x root x. So we'd be okay because that could be positive or negative. The x cubed can be lots of different, both signs. If it was square root of x to the 4, absolute value of x squared. Oh, x squared is always positive anyway, then it doesn't make a difference. But when you take an x squared to an x, you have always positive to now sometimes positive, sometimes negative. We have to keep it.
So it's like that in the case when
Pretty much. Wait, I said we had to go over 2, 6, and then we had to go over 2, 7, yeah? What do we want? Do we want baseball? Do we want triangle? Or do we want circle? Okay, that wasn't at all what I expected. Circle, here we go. I was expecting baseball, but you guys are like, we already did one of those. Okay. What's our first step? Given! After you draw a picture. Okay, that's exciting. Come over here. Maybe with him the picture wasn't all that necessary. Given! Fine. Okay, where does the given come from? Find me the wording. I'm finding R. Is the rate of change of A? Who's that? Rate of change of A. dA dt. Twice the rate of change of. Where are all the numbers? Anybody getting a little confused? Okay, well, yay, that was fun. What equations are we supposed to be using? Area. I guess he's important. And who else? I guess he's important. They didn't really tell me anything else, so what do you think I'm going to do? Let's take a derivative. I haven't got much else to do. Carla.
Will you give us those formulas from all the past one?
The only ones I wouldn't give you is like area of a rectangle triangle base times height, area of a square, side squared, area of a circle. Pretty much the area formulas I won't give you. Unless it's an equilateral triangle, then I might give it to you, but I don't think you have them. But any volume formulas? Or surface area formulas? Yeah, sure. Let's derive stuff, I guess. I don't know what else to do, right? So dA dt, who's he gonna equal? Pi is a constant. Bring down the 2. The pi is just chilling. Remember, the 2 comes down, joins the pi. R dr dt. Alright, let's do the circumference. So dc dt is equal to 2 pi is chilling. Derivative of r is 1 dr dt. Okay. Now what? Well, I see dA dt equals 2 times dc dt. Yeah, we could solve for dr dt. I'm going to do some plugging and chugging, some substituting. So dr dt is equal to who? 1 over 2 pi dc dt? I guess. Where are we going to plug and chug him into? Alright, let's go plug him in. That's our way to get dA dt and dc dt all together, right? So then we can go ahead and have dA dt. This is kind of our plugging and chugging. Equals 2 pi r times 1 over 2 pi right? Oh! Hey! Look! I can do that too. So then I have 2 dc dt is equal to, the 2 pi's cancel, that's r dc dt. Hey! No way! They gave me like nothing and I still figured it out. So did you. R equals. It's only one time that could possibly be true. Mind blown a little bit. Do you want to go back and do one with numbers?
Yeah.
Is that okay? What? Yeah, I know. There was like nothing, and still we did it. But there wasn't nothing. They gave us a clue, and we had 2 formulas, and then it just worked out. Okay. Spirit fingers. Okay, coming back. Oh, okay. These have numbers. Which one do you want? 5. Here's me, just because it's easier. Or is it because it has an angle?
Oh yeah, angle.
All right. Because of the angle. Number 5. Get in. Because we already have the picture, yeah? You see a number, go backwards. Rate of who? Okay, whenever you see the rate of, you can put the box always in. D theta dt. Is it increasing or decreasing? Positive or negative? Increasing. Okay, so positive, right? 2 radians per hour. Fine. Right? When? What's the formula? Pythagoreans, if I have all 3 sides, I have an angle and an opposite. Oh, and a hypotenuse. You gotta think about what you have. I have an angle and an opposite and a hypotenuse. Yeah? And some of you might want to rewrite that for sake of a derivative. That's a common. That's a lot easier, right? So now what? We've done our given, done our find, have our picture, have our relationship. Now let's derive it. So derivative of sine theta is? Ooh, look at you guys. Careful, stay humble. Keep looking. Equals 1/5. Stop. Last step. for d theta dt. So then we have cosine of times equals, well, dx dt is allowed to stay. He's the one I'm solving for. But they gave me x is 4. Can I just plug in for theta and be like, oh, they just said it wrong? But what we can do, remember what we did in all the problems in class? We go looking for him, right? Exactly. Well, I don't know if I want to do squared though. I want to use the formula I have because I want theta. So I would do sine of who is 1/5 times 4. Right? Plug in x and say, oh hey, I have an equation for that. Let's go find theta. Uh-oh, how would I find theta? Calculator, sine inverse. That's not a unit circle one. That would have to be a calculator problem. Okay? Somebody in radian mode, not degrees. Radian. I found a calculator in degrees today from a calculus kid. Radian, sine inverse of 4/5 is? Careful. When are we supposed to round? At the very end. So give me a few more. Oh, literally? That's even? No other decimals?
9.
Oh, okay. Okay. But that's even? No other numbers?
No.
9, 2, 7. Give me a few more.
2, 9.
Just to indicate, right? We don't round. Plug it in. Plug it in. How do you solve for dx dt? Algebra. Multiply to 5 to the other side. 5 times 2 is 10. 10 times cosine of, that yucky theta. Can someone keep their nice, like they store the number and just multiply it by 10? Well, cosine of that angle times 10. 6-ish?
It's 6 even.
Oh, that's impressive. Huh. Interesting. Okay, 6.
Wait. How do you find sine theta was 1?
Oh, I just plugged in x.
Oh, okay.
And some of you are like, wait a minute, why that worked out so nicely? If you know that he's 4, don't you know that he's 3? And if you just need cosine anyway, couldn't you just say he's 3/5 times? But either way works. Probably.
Is there an easy way of knowing, like, okay, you know how you said, like, the rate of, whatever you see rate of, that's going to be the given. Is there an easy way of knowing for the find fill or whatever it's going to be?
Yeah, same thing. Just think rate of box indicates d box dt. Now remember, they can say it different ways. They can say rate of box. They can say box is rate. They can say box is increasing at. They can say at whatever box is increasing or decreasing, etc. So whenever you see rate or increasing or decreasing, find the box. Find who is doing that. So when I saw rate of 2, who's doing that? Constant increasing. Oh, theta's doing that. So then he was my d theta dt. Then keep reading. Find the question mark. Work your way backwards. That's just a such that. Increasing. Who's increasing? X is increasing. Oh, X is rate. Dx dt. Does that make sense? So you find the box. You find who it is that's doing that movement. So for the given, you find the statement. Whose rate you already know. The find, you figure out whose rate you want to know. And that's how you find the d theta dt and the dx dt.
How do you figure out, like, x over 5?
Oh, just because the picture. They told me this angle is theta. So then I just said, who's this? Opposite. Who's this? Hypotenuse. And when I chose sine, sine says opposite over hypotenuse. I guess you could have chosen cosecant, hypotenuse over opposite, but
So that's like something else we should also know.
yeah, it's kind of like back in pre-cal when I would give you information for a triangle and I would say solve for this extra piece. You had to look and say, okay, which sides do I have and which angle do I want and how can I use trig to get me there? So it's kind of like those skills. With triangles, just think which side to theta, opposite, hypotenuse, and that leads you to sine. And then think SOHCAHTOA, opposite over hypotenuse, and then just kind of fit in the clues where I need them to go. Okay. Kiddos, have we reviewed 2.5, 2.6, and 2.7? Yes. I'm going to go ahead and throw up on the board numbers 1 and 2 in just a second. And there's some we skipped. We didn't do number 4. We didn't do number 6. But I think we did all the big problems. If you guys want to play around with 1 and 2 right now, you most definitely may. But let me go ahead and get those questions back. That's not it. There we go. We still have like almost 5 minutes, maybe a little bit more. Do I have any volunteers for points for 20, 29, 20B, I should say? 29, 74, or 104? Yeah, Lucy, what do you want? 29? Okay, it's yours. Come on up, grab a marker. Everybody's, oh, 20B or 74 or 104? Ryan, what do you want?
20B.
Look at him, stealing points from period 6. Okay, we have to review one. 74 or 104?
I came in a minute into the period.
What's going on?
I would
What's
have.
the beginning? You're just like, can I? And I was like, yeah.
I would have done this morning together.
I noticed that halfway through, I noticed something moving back there, so I'm like, oh.
Wait a minute, 74 or 104? I love this conversation.
So, I'll just all review.
I haven't even tried the
I know,
test
but if you
review.
look at them, just try and let them board now.
Okay, wait, let me look at what page? 294. I'll look at it real quick. Is that 294?
Yeah, I think so. 284? 204? 204.
204?
I wrote 294 on my paper.
I wrote 294 on my paper.
I'm trying to do that for you.
What is it? 74?
74 or 104?
Oh my gosh.
Gabby, what do you want? Okay, Gabby's trying 104. Who wants
Oh,
74?
that's the easy one.
Kyle, it's all yours. All right, come on.
Wait, I have a question. What's implicit differentiation? Is that just to
I'll do it.
divide?
Oh.
Oh. The rest of you guys, if you have any particular questions, hey, I'm all yours. I saw Chris first. I think Chris.
What's your question? Maybe I can. Oh. Wait. You have to multiply
Yeah, I know. Like,
No, I know.
No, that's.
Yeah.
Here. I don't even remember. Oh, I'm gonna try that. If you can't solve, then you are
It's nasty. Wait,
Oh, I was
Which one was the period with you? Is that you guys' period?
No, I didn't have to work.
And then
Okay, because he was in
That was second period after one.
No, with Shane.
Thirty-five.
Oh, okay, because I remember you got out. I need to.
I literally don't remember. She's like, I went
And then we went back to your house, and we were supposed to sleep over, and Octavia got sick in the middle of the night. You go home. And then the next day we're like doing proofs.
Girly thing.
These sides of how fast.
I don't even know how I feel.
My math is
I'm
Wait.
It's like 3 hours.
Yeah.
It's like 3 hours. I'm gonna hit that. This is how this is going.
That's the derivative of sine theta.
That's all they gave you, right?
Yeah.
Yeah.
No.
But theta was constant at 18.
What number was that? I feel like 20.
1.6. Like when you derive it, all the things like that matter like disappear. So like you solved it. I forgot how.
Alright, kiddos, I'll be here after school if you need me.
I'm proud of you.
Okay, this is constant.
Yeah.
So you knew. What was it,
275.
miles per hour?
Yeah. I mean, I knew it.
You're trying to find.
Yeah. Yeah.
I like no. I have like one or two. I mean,
Don't worry,
I'll
Kara.
send you if there's a period.
What are you worrying?
I'm worrying.
Oops.
Yeah, don't try to be cool, alright? Yeah, don't try to be cool, man. You go this way. I can do this. Guys. Chris, no! Okay, so we're gonna find the derivative of 2x, right?
Yeah.
So, actually, I don't think I can do that.
I'll be back. Come on.
There we go.
This was the last chapter. This was like one chapter ago. Chris, there's no saving. Okay. Hang on, here, extra point. 270, you want to try.
I was looking at notes, use it a different way. Like, I know this is 0,
Pass the news.
and this is negative sign, but don't take this out, so plus, and you say don't repeat coefficient, so would that be the same as percentage? And no one else changed it to use triples, and changed it to sign.
How did you get a B in that? Like, how?
I didn't get a B. No.
Yeah,
first one.
Now, B in algebra. What's so hard enough?
Just algebra 2.
Just algebra.
Because I will make it cosine plus.
I got a B in algebra 2 because Cocker got it. I got it. He didn't hate me. Yeah, he didn't hate me.
You could have made it cosine times cosine and done a product rule. And if you understand, change what's next. Like I would rather do cosine x squared than cosine x times cosine x. You know what I mean? That would be a little easier. What's wrong, kid?
It's the worst. I forgot my bag was in here, so I walked all the way to the locker room and realized it, and then I would have to walk all the way here and all the way
Oh
back.
my goodness, there you go running soccer.
I need to